All right, so we've talked about arrays, how arrays are this structure where it's we kind of have like a box, and then each item gets to live in one spot in that box. Arrays have downsides where once you fill them up, you can't expand it. You've got to make a new one. That's the whole point of the lab to reallocation activity. And so lists are a kind of more advanced type that kind of takes those problems away from you. So in Python, this was what you did a lot of the time, where you didn't have to worry about reallocation. You could put whatever sort of stuff you want in it. And so lists are kind of Java's way of making that a little bit better. So we'll talk about what are they, how do we set them up, how do we use them, and then what kinds of lists can we use. So lists are a data type. They're a type, a reference type. And I have that sentence here. Java's helpful way of handing us an object to work with. I don't know what that means. This happens sometimes where I make slides and then one semester it sounds great and the other semester it doesn't. Anyway, so Java is, so a list will represent it the same as an array. But instead of arrays, it does the reallocation for you, and it has some cool features that arrays don't. So we declare it like any other reference variable, except it's a little bit different, where we need to say, so remember, declaring a reference variable starts with the type, and then the variable name. Then that's it for declaring. But we have this addition of these, what we call angle brackets, the less than or greater than. And this is a little bit different about lists. What that's doing is it's saying, here's the type of thing that's going to go in the array. So when we declare an array of ints, we have these brackets to show that it goes in an array, that this is going to be an array variable. We have this to say, here's what kind of thing will live in the array. And so here we say that it's going to be a list. And then here we say, here's what kind of thing will be in the list. So we're still restricted to only having one type of thing in our list. And the way we say that is within those angle brackets. So let's try that out. Let's say I want to have a list of integers. So I know int is my type name. I'm going to say list int my list. You can see everything's not good so far. I have a red squiggly line under int, which says, if I hover over this, will it zoom? Syntax error to insert dimensions to complete reference type. Okay, I don't know what that means. Spaces don't matter. And so something that we'll talk about later, and something that we saw a little bit when we were talking about like parsing. Where's that? Parsing. Remember when we have the capital D double or capital I integer, capital B Boolean? So the only things that can go inside lists are reference types. So only reference types are allowed inside lists, not primitive types. But there could be a point where we actually do want to include primitives in our list. And so we do that by Java provides this type as kind of like a wrapper of, you gave me a primitive type, I'm going to pretend it's a reference type so that all this stuff can work. But then when you need to use it, it'll unwrap it for you and say, here's your primitive again. So the capital D double, capital I integer, capital B Boolean. That's just a wrapper type that pretends that it's a reference type. So since the only things that can go in lists are reference types, we need to say, I want you to contain integers. And you're going to pretend that they're reference types to make everything happy. The other error we have over here is that it doesn't know what list is. List cannot be resolved to a type. And so this lives in the Java library, and so we have to import it. So if you hover over it, this quick fixes shows up. There's all these different options. The first one is the one that we care about, to just import it from java.util. Once I click that, then a line shows up at the almost top of my code saying import java.util.list. And now it's happy. The errors are gone. If the errors aren't gone, like up here, it still has the error icon, then the file's not saved. So if I save the file, now the errors are gone. Great. So we had to say, pretend this integer is a reference type by saying capital I integer, and we had to import it from java.util. Okay, so that's declaring. To instantiate, to actually create the object in memory, we need to have the new keyword. And then the right-hand side is going to be, we'll make it array list for reasons. We'll talk about a little bit why later. And so we say, let's call it list one, and then we'll declare and instantiate all in one line. List integer, we'll call it list two, is equal to, and then just like with other reference types, we need the keyword new, and it turns pretty colors. We need the type of thing that we're instantiating. Remember, we're calling the constructor. So for this, I need array list, and then the angle brackets again. Now, I can put integer in here. I could also leave it blank, because Java is smart enough to know that if I put integer here, it's like, okay, I know what's going to go in there. You're going to have a list of integers. So we could put integer here if we wanted to be safe, or we could just leave it blank. So we have to use array list. We'll talk about this later when we get to like interfaces. But array lists are a more specific type of list of how is this actually implemented in memory. And so array list is implemented, you might have guessed, using arrays. And so we have to say, I want to make a list. Here's the specific kind of list that I want to make. So list is more general. It's a broad term. And we need to be specific and say, here's what kind of way we'll represent it in memory. And so we have an error that says it doesn't know what that is. It cannot be resolved to a type. And the solution here is, again, to just import it. Great. The errors are gone. All right, so that's declaring, left-hand side of the equal sign, instantiation, the right-hand side of the equal sign. So let's talk about how we use it. So with arrays, we could say, like, let's say we have array one defined. We can use the square brackets and say array one at space 0 is equal to, say, 34. But we can't do that with lists. So let's try and do that with list 2. I get an error saying the type of the expression must be an array type, but it resolved to list integer. And so what that's saying is, you gave me something that I know how to do with arrays, but you've given me a list, and I don't know how to do that with lists. So we cannot do this. Instead, we have to use dot operations. We have to use methods. And so with lists, we can, where's my cursor? We can add. So if I type add, then this little box pops up and I'll just choose the first one so I can press enter. And let's add 2. And we'll add 99. So we can add things that way. If we wanted to add a whole bunch of numbers, we could make a whole big long list of adds, or could like put it in a loop and just add them that way. So add item. And what that does is that's like in Python when you append to a list. So you just add it to the end of the list. So if this is our item, our list, first we have 2, and then we add on 99. And then if we add on 37, it just adds it on to the end. And again, what's happening under the hood is that reallocation, but we just don't have to see those details now. We've kind of risen above that. So that's kind of why you'll see if we need to have a list of things in class, then I will tend to use lists so that I don't need to deal with reallocation. There's other options for adding things. Add last also adds to the last element in the list. So these two are equivalent. And there's also add first, which is where we can add it to the beginning. So if we wanted to add, let's say 25 to the beginning, we can do that. So let's list 2.add 39, I think it was, and then we can start typing add first, and then it pops up for me. So I'll hit enter, and then 25. So I know when you print arrays, it's not pretty. What happens when you print lists? The words. So lists have a toString built in so that you can print them and it looks pretty. This is another reason you'll see me using these in lecture a lot because it makes those things easier. And you can see that 2, 99, and 39 are there, but we've added 25 ahead of the others. To remove things, you can use .remove. There's 2 options. So one of them, if you want to give it the index, to take out the thing at that index and remove it. The other option is to go through the list, find the first instance of some item and remove it. This gets tricky when your stuff in the list is integers, because if I ask to remove 2, what am I asking? Am I asking to get rid of, so if it's indexed 0, 1, 2, so either I'm asking to remove the value 2 in my list or the second indexed value, which is 99. So be careful about this if you've got a list full of integers. Let's see what happens when we do it. So int index or object O, let's try that. And then let's see if we can, no, we can't enter it. The other thing is once you type the variable name and the dot, then the little box pops up and you can scroll through. Here are all the different things I could do. So actually, so let's just remove 2 and then see what happened. So I'm honestly not sure which one's going to happen. Who votes that 2 gets thrown out? Who votes that 99 gets thrown out? Okay, so it's a toss-up. 99 got thrown out. Okay. Let's see if I can. So I selected the index. If I select the other one, 99 still gets thrown out. So what this tells you is when the items in your list are ints and you call remove, it's always gonna remove the index item rather than searching for the actual object too in your list. So something to be careful of. If we want to remove everything from the list, we can use .clear. Again, these are all things that pop up when you press the period key. And so you can scroll through and see so if I do this list 2, then you can, if you use your arrow keys, the documentation shows up on the right and you can read through. So like, what does clear do? Oh, it removes all of the elements from this list. What does equals do? It compares the specified object with this list for equality. And so you can go through and see all of that documentation, which is really useful. To access items, so instead of doing something like instead of using angle brackets to just get an item, I need to say .get. And then that will allow me to receive that indexed item. Get first, get last are fairly self-explanatory. To see how many things are in it, we can say let's size. Again, this is a method, so we need the open and close parentheses. And then if we run that, we see that there are 3 things in our list. All right. We can also check if the list contains something in there. So .contains, and if we give it an item, it'll search through it and tell us, yes, it's there, no, it's not. And we can print it, unlike arrays, which is nice. Okay. Any questions on lists? Maybe you did the packet and you're super confused. Great. So now you should be able to do those questions, and you should have all those tools at your disposal. All right, let's do not lab. We're doing input output. So now we're in a new unit, and this is something that you kind of went over maybe on the first couple days of Python, but here it's a little bit different, which is why we've taken so long to get there. So we're going to talk about how to get input with the scanner. We're going to talk about how things go horribly wrong and how to fix it. And then we're going to talk about how do we read things, how do we write things. That's all going to help you prepare for Lab 3 and Homework 2. Lab 3 is truly like the easier task of this, and Homework 2 is the harder task of this. Homework 2, so Lab 3 is more like practice of the things we'll talk about today. Homework 2 is split into 2 parts. Let me pull that up. Where Homework 2 is under Unit 3, where the first half is going to be work on an easy game, easy in quotes, because scanners are hard, which is rock, paper, scissors. So computer asks, what's your move? You type rock, and then the computer randomly decides, here's who wins, and then prints the result. And then it asks, do you want to play again? So that's fairly straightforward. And then that's the easy game. And then you have a hard game, which you've got options. So you could make a game that's tic-tac-toe. So you print an empty game board, and then the user inputs, here's where I want to place a move or a piece. The computer decides where it moves, and it repeats until the game is won or scratch. You could also do a choose your own adventure game. So telling some story, and the point is you get input, decide what happens, and print stuff to move it along. You could also do hangman, which is where a user guesses some letters. You can get creative as you want for how to print all this information. And then, yeah, so the user is guessing the secret word. If you have an idea for something else to do for homework 2, absolutely. Come talk with me about it. I can help. So I say with instructor approval, because sometimes the ideas could be like way up here for kind of like a more simple project. So let's talk about it first and make sure that it's appropriate for this assignment. Okay, so that's where we're going with homework 2. Hopefully that's fun. I know students in the past semester have had a lot of fun with that, so I hope so too. No packet for this one, but we will have Zybooks just to help give you another chance to read about this material. So in Python, your first day, you probably learned input, where you type the word input and you save it to a variable. And so you can do something like that, right? Or like int is a reserved Python word in Python. So you can say like my int equals input, give me an int. That works on the first day. In Java, it's more complicated. So we had to talk a little bit about objects in order to get started with this, because we're going to use a scanner to get the input from the command line, from the console. A scanner is a reference type, which is why we've waited to talk about it till now. It takes input from somewhere, so either from the console, the command line, system.in, or from a file or a file reader. And so it takes input from somewhere, and then we can use that input in our code. This is a picture I found on the internet that kind of describes how scanners work. Have you ever been to like a stream where if you like throw a leaf in the stream, you can see it as it meanders away from you, and then you throw another thing in the stream and it keeps on going? We call this an input stream. So as I type letters, that's me throwing leaves into the river, right? There's an order to it. So if I type, so what is this sentence? 1, 2, 3, ABC, 1, 2. And so 1 gets caught first, and then 2, and then 3. And then I type a space with a space bar. And so as it goes, all of these characters get captured and put in this buffer. And so the scanner's job is to read that buffer and then give us things out of that. So we'll start off by using scanners with system.in. The general syntax is to say, here's the type name. The type name is scanner. The variable name is whatever we want it to be. We'll need the new keyword. Again, the type name, capital S, scanner. And then we call scanner's constructor. And scanner's constructor needs the input source. And so we'll use it with system.in. So this is the counterpart to system.out, which we use to print things to the console. To get things from the console, we need to say system.in. All right, I'm going to make a new package for this one. I'm going to comment that out because that's not doing anything. So command N, class, next. I'm going to put it in a new package because we're in a new unit. So I'll call it U3 underscore IO for input output. I'll call it scanner demo, and I will give it a main method. All right. New package, name is scanner demo, main method. All right. So to create a scanner, again, I type the name of the type, which is capital S scanner. I'll call it in to tell myself that's just the variable name that I'm getting. The scanner is coming from system input. I could call it sysin or whatever I want because it's just a variable name and it could be anything. So now I have to give the arguments to the constructor system.in. So, okay, that turned pretty colors. That did not. It says scanner cannot be resolved to a type. What's the problem here? It doesn't know what scanner is, but scanner is a well-defined class, again, in Java utils, so we just need to import it. So once we do that, and we save the file, those errors are gone, and we should be okay to go. Is everyone able to get scanners not angry at them with the red squiggly lines? Great. If you're unable, come talk with me afterwards. Okay. So we've set this up. Now we need to be able to do something with it. So to do that, we need to understand how scanners work. So again, this is an input stream, and scanners typically break things up into tokens. Tokens are usually things that are separated by spaces or by new lines. So white space is what separates any text into tokens. And so if I type, hello, this is a sentence in the scanner, then to get the next word, so okay, this is another thing. This is what we call a queue, which we will talk about later in the semester. A queue is something where, like, if you're in line if you have your basket at Safeway and you want to go get in line to get checked out, you join the line, and then once the teller is ready, you leave the line. That's the idea of a queue. And so when we insert things into the scanner, we type hello first. And then we say this, and then is, right? That's the order of which we type things. So when we get something from the scanner, that first thing that we send to it becomes the first thing that we grab. So we said hello first, hello comes out first. We sent the word scanner last, the word scanner comes out last. That's a queue. And so we can get that information with s.next. So let's test it out. So we'll have some prompt. So I need to print to the console for the prompt. So I'll say, please enter your name. And then I need to get the input, which is in.next. So in is the name of the variable. If I click on it and highlight it, then it highlights where we defined it. And then I need to save that information to somewhere. I need to catch it. And so the type of things that scanner works with are strings. It'll give you strings. And then if you give information like a number that's not a string, then you need to parse it to kind of convert it into something you can do computation with. But as a basis, the thing scanner is going to give you is a string. And so in this case, I know that I want a name. And so I'll say string name is equal to in.next. And then we'll just confirm. And then we'll do some concatenation here with the plus to say, here's what your name is. All right, let's try it. All right, so already we've printed to system.out. And so the console shows up as I'm ready for you to enter your name. I can type something. Notice that it comes up a different color for me. That's to help emphasize that I'm the one typing this and that's not something that the program decided to print. And so then once I'm done, I'll hit enter. And then it says confirming your name is Sarah. Questions on that? Let's try it if I do just gibberish. What happened here? Yeah.
Space, I'm guessing.
Yeah. So next takes in just the next token. And so the tokens are denoted by white space. So once it hits white space, then we're done. Notice when I did it the first time and I just typed my name and then hit enter, then it was like, okay, white space, I'm done. Here you go. Here I can type all the white space. I can type a space and then give it whatever I want after that. It's going to ignore all that, only up to the first white space. I can also give it like numbers. And yeah, so whatever I give it, even if it's a number, it's going to take it in as a string with no complaints and then print it up to the first white space. So this takes a little bit of practice. That's also what the lab is designed to do. All right. So if you're at a point where I'm talking about scanners and you don't know how they work, there's always the option to Google how does a scanner work. And the people who wrote Java, or people who now own Java, Oracle, they have documentation to tell you here's how a scanner works. So I don't think this link works. So let's actually make it a link. And click there. And this is the documentation for a scanner. So when you are working with some type that Java has defined and you don't know how it works, I strongly, strongly recommend that you read the documentation. And so the official docs.oracle.com, that's the official documentation. But since lots of people learn Java, there's resources other places on the internet as well. So the way the documentation works out is there's a lot of words here that we don't really understand yet. This is pretty much everything that you need to know regarding a scanner. So not all of it's going to be interesting or of use to us at the moment. So like there's extends and implements, which we don't really know what those are yet. It has some introductory things to say, here's a scanner in use. And so you can go through that and see if that helps you understand what's going on. And this is telling you, let's see, localized numbers. Okay, so all of this up above is kind of the introduction. Then we get into, here's the constructors. Here's where we can construct this object. Here's information on all the methods. And then there's a lot of methods. Other methods inherited, and then more detail on each of the things. So that's the documentation. In terms of the methods that we'll tend to use in this class, just next, we'll take in any token, no matter what it is. There's also some easier things. So where if we want to take in the entire line, so let's say if I wanted to ask for it to take my whole name, it's not going to do that. But if I wanted to take the whole name, then I could say next line instead. And then it would take my entire name. So everything I type on the line will get output from there. If I input a Boolean and I want it to, it has some support for primitives to, if I have a Boolean, a double, or an int, it can grab that information from the scanner and return it to me as an int, as a double, as a Boolean, which is nice. And then we have to talk about what happens when things go horribly wrong. So let's consider an example where, okay, I'm going to comment these guys out. And I'm going to ask for a number. And I'm going to grab the next int. Confirming your number is and then I'll give it X, right? Same thing as we had before, just I'm going to get this number as an integer. So if I do that and I give it 3, 4, 5, 6, 7, and I hit enter, then confirming your number is 3, 4, 5, 6, 7. Great. And now we can actually do math with this int. But what if I give it something other than a number? If I give it a string? Then something bad happened. All right, so this is practice in reading error messages. It says exception in thread main, java.util.input mismatch exception. And then it gives us, here's where things went wrong. Things went wrong in scanner.java, line 964, and line 1619, 2284, 2238. And finally, something went wrong in scanner.demo.java, line 16. All the stuff in scanner.java, I don't have any control over. So the issue that I can control is what happened at line 16 in my file, which is, this is telling me that's where something went wrong. And as for what went wrong, it's input mismatch exception. And so what happened here is I'm expecting to catch an int, but I was not given an int. And so that's the exception, saying I'm expecting something of one type, but I was given something else. There's a mismatch as to the type that I received. Input mismatch exception. And so exceptions are objects that store information. So pretty much everything in Java is an object or something like that. Exceptions are objects. Scanners are objects. Exceptions are objects that store information about stuff that goes wrong. And then they get moved through the calling sequence until something catches it. And then you can extract information of, oh, that went wrong. Okay, I'm going to report that to the user and maybe end execution. Exceptions will see try catch. They're not necessarily like if else. If else is Like if this happens, then do this, usually with some conditional. Exceptions are when things break. And so these are abnormal occurrences that we ideally don't want to have to satisfy. This is how it's going to look. We're going to have the word try, we're going to have some risky code, and then after that, we'll have catch blocks to say, here's one case where things could go wrong, here's another case, and so on. And so this is a step that you need to think about as you design it. So as I'm designing my small program, I need to think, oh, I'm expecting an integer. What if I don't get an integer? So this is where, as designers, you kind of need to think, how could someone hack this? How could someone do something that I'm not intending for them to do? And so if I'm saying I'm really sure that I'm going to get an int, the possibility is that I don't. And so we need to put this in a try catch. So we have some risky code. So I'll put that in try. It's not formatted nicely, so I'll right click on source and then click format. That didn't fix it because I have an error. The error on the end of the try bracket says syntax error, insert finally to complete try statement. The reason is we're not done yet. So we have our risky code inside the try block. Then we need to say what kind of bad things could happen. And so after the try, we need catch. And so I know one of the issues that can happen, because we just ran into that, and that's input mismatch exception. This is a type, and so I'm going to say that so it's a type, and I'm going to give it a name to make it a variable. So I can call it E, I can call it input mismatch exception, INE for the initials. And then I can do several different things. So I can print a system.error. So instead of sysout, if you type syserr, or you can just type out system.err.println. And this prints in the error stream, which is, it gives us the red text instead of the black text. So I can print something to system.error. I could also print the stack trace to show something like this that happened. So let's try that. So first, let's test that it works under normal conditions. And it does. Great, nothing happens. Now let's test abnormal conditions. And it prints pretty much the same thing, where it says, you didn't give me an int, except I typed that. And then it prints this list of here's where things went wrong, here's the line numbers, and that's called the stack trace. We'll talk about stacks later in the semester. So we can give as much or as little information to the user for what went wrong as we need to. So we don't have to have only one catch. If other catches, if other exceptions could happen, we can have those. And we'll also probably need a finally block. So after this code executes, so regardless of after try or catch, then we need a finally block. And finally, does not take any parameters or arguments, so no parentheses, just curly brackets. And then we say in dot close. And so this is something where this is resource management. So we open the input stream when we have the right-hand side of this statement. And so once we're done, we have to close the input stream. So what we open, we have to close. And here we've got a warning of it's never closed. And so even though we close it down here, we just have to restructure it a little to make sure that it's happy about it. So we can start off by saying, okay, I'm going to have a scanner and it's going to be nothing for now. And then I can create it and I can actually open the scanner in the try block. This is going to be what we prefer, especially when we're reading files, because sometimes you go to read a file and it's not there. And so this step could cause an error, where if I'm trying to get input from something that doesn't exist, then it's going to crash. So you'll see this happen a lot. So if we do that and save, then that warning goes away and we've successfully protected our code from when things go horribly wrong. So please give me a number. No. And then the same thing happens. You didn't give me an int. And we freed our code from warnings. Here's a list of common exceptions. Input mismatch exception is not on here. You've probably seen before the index out of bounds exception. Oh no, I exited out, so I have to redo the pen. You've probably seen the index out of bounds exception. Going forward, you might see null pointer exception. And when we talk about files, you'll probably see file not found, as in, where is it? I don't see it, or some general IO exception. So technically, when a runtime exception occurs, then you have to be kind of careful about how you proceed. So it says, so runtime exceptions tend to be serious errors depending on the project. Like I've written code that has exceptions, but I need it to keep going. So like if I'm having my code process a data set and one file breaks it, I don't want the whole program to crash. I just want you to move on from that file. And so it kind of depends on what sort of thing you're doing. Generally, when you find an error and you want it to keep going, then you throw in a try catch and then you can move on. You can also throw a new exception. You can also define your own exceptions. We'll maybe talk about that later on. All right. We've got time for our activity. And so I'm going to show you 3 ways of reading 2 ints on the command line. One of them we're going to do without try catch. One of them we will do with try catch. And then there's another case of what if there's other stuff on the line that we don't want that to happen. Right, I'll make a new class for this just so it's where I need it to be. My issue right now is I went to go make a new class and it doesn't know where my source folder is and it doesn't know what package I want to be in. I know what package I want it to be in, so I'll just hit cancel really quick. Click on the package I do want it to be in, U3IO, and go through that process again, and now it's auto-filled. So now it knows I want it to live in this project and the package of U3IO. Okay, So what do I want to call this? I'm going to read to ints. So I'll call it read to ints. And I'll give it a main so that I can actually run things. All right. So for each one, so for without try catch, with try catch, nothing else on the line, I'll make a method for each one so that we can call the specific one that we want to use. So I'll make a method. It's going to be public. It's going to be static because we don't need a read to ints object. And is it going to return anything? No. We'll call it no try catch. And this is going to be the same as before, right? So sysout, give me two ints. And then we'll say we have to initialize the scanner. So scanner in equals new scanner coming from system.in. And again, in this file, it doesn't know where scanner is or what it is. And so I just need to import it. And then the errors go away. So once I've got my scanner set up, I need to grab the two ints. So I'll declare and initialize them all in one line to just say int x is equal to grab the next int from our scanner. Int y is, again, grab the next int from our scanner. And then finally, we'll print a confirmation message. To say, you gave me x and y. All right. Oops. All right, so that's the main idea. And let's test it out. So in main, we'll call no try catch. It turns italics because it's a static method. And if we run it, give me two ints. If I give it 2 and 3 and hit enter, you gave me 2 and 3. So it works at least. But now we're going to try and break it. Where this is where we think like a hacker of what could go wrong here. What did the designers not anticipate? And so we could say maybe 2, 3, and 4. So we've hidden extra data here. Or what if we're expected to give 2 ints. If we give 3, nothing happens to the third. But if we only give 1, I hit enter and enter and enter and enter and enter, nothing's happening. To stop, to say I'm done giving you something, we could say, I think it's Control C, Command C. I forget what the end of input. I know in Mac, in terminal, it's either Control C or Command period, sometimes Control E. Nope, that's not it. Nope. Okay. So in any case, I can't, once I figure out what that key binding is, then I could be like, no, I'm done. So for now, that's probably okay. If I just stop, then I stopped the terminal. It didn't give me any errors, but it also didn't proceed with, you gave me this. And so the other thing that can go wrong is like if I give some key smashes, then it gives me the input mismatch exception. If I give it like some number, but something that's really not a number, then I get the input mismatch exception again. One thing in my notes that I should probably tell you about is, so there's a possibility that the thing you get, so because the stuff that you get from the scanner, you don't really know exactly what's coming. You can have a good guess and you can tell the user and prompt them, here's what's going to happen. Give me this information. But one way you can fix this is to check first. So you can ask the scanner, what's next in the pipeline? So I can ask, first of all, I can ask has next. So is there something else? Not restricting that at all. Is there another token? I can also say, is there another int coming my way? Then if there's another int, I can, so if I move this in, then y is going to be out of scope down here. Then, so I can fix this by just declaring x and y out here. So then I can say if in dot has next int, then grab that, and then here 0 x and y may not have been initialized. So let's see if that works. So maybe we just need to give it, we can give it 0 and 0 to start with. And then if we get something other than 0 and 0, then we will print that information. Does that work? No, it doesn't. Okay, so we can't do that. So we can declare it all on one line, like int x comma y, that's declaring, but we can't initialize both of them on one line. So we have to say int x equals 0, int y equals 0. So this should work. So this should check for if the next thing is an int. So let's check that. So first off, our normal input works as intended. If I say 2 and no, then it says you gave me 2 and 0, where 0 was our default value. If I give it no way, now it's going to print 0 and 0. So this is one way of kind of avoiding that issue. All right, let's do this with try catch. So outside of the curly brackets, we'll make a new method. And we'll be safe like last time and start off scanner as being null. So nothing, non-initialized yet. But we've declared it and set it up to be nothing, so we can do something with it later. So scanner in is equal to null. And then we'll print the prompt. Please enter two ints. And then we're being safe about it. So we're gonna use try catch. So we'll have try, then after catch, and then finally. So that currently gives us an error because we haven't done anything here yet. So the thing with scanners with try catch is you type something, you get an error, you keep going and finish your thought, and then you check to see if there's errors. So we will say, so in this case, we could bring the, if it has a next int, if it has a next int. In this case, I'll just say in.nextInt. And of course, I have forgotten to actually instantiate my scanner. So I need to say in is equal to new scanner of system dot in. So that's how I actually get the information in. Again, it's just grabbing the next int from the scanner and then printing them. In terms of errors that can happen, I know input mismatch is a big one, so let's do that. So in the catch arguments, I'll type input mismatch exception, and I'll call it E this time. And let's just say E dot print stack trace. And we'll print a sys error. Of your ints were not entered as required, please provide two ints. So again, same as before. I've got a warning over my scanner instantiation saying resource leak in is never closed. And that tells me that I have to put something in finally to say in.close. That doesn't give me an error. It could maybe. So sometimes what happens is if something goes wrong, we'll see this especially with file types. If something goes wrong at this step in loading up the scanner, then it'll go here and it's like, well, I never fully opened the scanner, and so I can't really close it. And so one way to kind of protect us from that is to say if in is not null. So if we got past this point, then close it. So if it's not null, then we close it. Otherwise, if it is null, then we don't have anything to worry about. All right, so that's my way of doing it with try catch. Any questions so far? All right, let's test it out. So I've written my method. Now I have to call my method in main to make sure it actually runs. So instead of no try catch, I will call with try catch in my main method. It turns italics because it's a static method. There's no controlling object. And let's run it. So intended usage works. If I give one and no, then it gives me my error text and the stack trace. If I give it no and way. Oh, what? Oh, I think I pressed run again. If I give it no way, then it also gives me that error message. If I give it 1, 2, 3, 4, and 5, 6, it just says 12 and 34. And so this is the thing that we're going to try and tackle next. Because maybe it's the case that we get two integers, but then maybe there's some secret info later on, or maybe someone's trying to hack us, and we don't want that to be allowed. So we only want two ints on the input line and nothing else. So this is a way to kind of sanitize our data. So this is what we want to stop. We want it to not have anything else on the line. So let's write that method now. So we'll call it no other info allowed. All right. So what I'm going to do, I'm going to have a lot of the same code as the try catch method. So I'm going to copy everything inside the method curly braces. So this is the open curly brace for with try catch. That's the close curly brace. So I'm going to copy everything inside that and then move it to my new method and then just make some small changes. So I will copy, Command C, or edit copy. And then in here between the curly brackets, I will say Command V and paste. Some of the formatting didn't paste. I can fix that manually, or I can right click on my code and go to source, format, and that fixes it. So again, I pasted it, it didn't look good. Right click on the code, go down to source, and then format. Okay. So when I'm trying to not allow for any other data, these three lines are what I want to look at. That's when I'm actually getting the input in. So I'm going to try something new and say, or actually it's these two lines in particular. So so as the designer, now I'm going to assume that someone could have given me extra information. And so I want to make sure that only two things are allowed. There's a lot of different ways I could do this. This is one of the stages in Java that you're starting to get to where the way that I think to do this can be different from the way that you think to do this. That doesn't mean that either of them are wrong. They're just different. So I'm going to say, I'm going to assume that there's potentially many things that are coming in on my scanner. So I'm going to go through all of them, and I'm just going to stop after 2. And so I'm going to use a method that the scanner has to say, is there something next? So in dot has next. So whatever it is, I'm going to look at it. So I'm going to actually, so let's start. My while loop needs a counter. And I also need to declare X and Y for if I get them and it's all correct. Maybe we'll have them be -1 this time. And they should be X and Y. So okay. All right. I think I wanted to show you what it looks like to have a while loop, but I don't know that it makes sense at this point in time. So this is also something that can happen as you design code where you're like, I think this is going to work. And then you reach a point where you're like, I don't know if this is going to work. Where I'm trying to think, is there a way for me to use the while loop to catch the two things X and Y? The problem that's coming up in my head is that I want the first int to be X and the next int to be Y. And so to do that, I think it's going to be super complicated to use like I equals 0 or I equals 1. And I kind of don't want to go through all that trouble. So let's do something simpler instead. So I'm going to delete this part. And then say instead, so first we're going to check for sure if the next thing is an int. So if in.has next int, then x equals in.next int. The difference between these two function has next int and next int is really important. So if I give it 1, 2, 3, 4 and some secret info, when I'm here at the very beginning, I'm asking, does it have a next int? What's the answer? Yes, right? 12 is next. So the answer to has next int would be true. Once that's done, then I say in.nextInt. Saying in.nextInt actually grabs 12 from the input stream, removes it, and hands it to me to the variable x. So that's the example where we go all the way back over here. Once we grab s.next, once we call next and not has next, because has next is a question. Next is an action where it takes the thing, removes it from the scanner, returns it to me. So if it has a next int, then grab it. And then we want to do that twice because we want to grab x and y. And we want to make sure that it's an int. And so we say y is equal to in dot next int. And then we can print. But we don't want to allow for any other information. So if something goes wrong, then we won't grab the integer. It'll go to an input mismatch exception. Something goes wrong here, it won't grab it as an integer. And then once we grab our two integers, we want to ask, is there anything else there? And so we don't want to be specific about that. We don't want to ask, is there an integer? We just want to say, is there anything else? Then once that happens, let's print to system error. There's other data on the line. And I will say, I'm not sure if this is going to work. And it does. So I can print, here's my error, and also throw this exception of the input is mismatched from what I expected it to be. And only once we've checked that can we say, here's what you gave me, X and Y. So let's check that. So if I run it now, it's just going to do the old one. So I'll comment out and what's this method called? No other info allowed. We'll save that and run it. 1 and 2. Yep. Oh, okay. So I'm in the case where I can't keep going. I've made an error in my code. Where is it? So I'm at the point where I've inputted 1 and 2, right? So we're past this, we're past this. So now we're looking at anything else on the line. So the issue is in this if statement. So it's asking for if there's anything next. And so now it's like, okay, I'm waiting for something next, give me something next. And so if I type something here and then hit enter, then it prints other data is on the line. So I have to restructure this a little bit. So, and now I need to think of what are the cases that I want. So if there's anything else on the line that I want to these two lines to happen, if there's no other data on the line, I want this print statement to happen. So let me change this a little bit. So if there's nothing left, then I want this to print. So I'm going to move this line of code up really easily by pressing Option or Alt on Windows and then the up arrow key. Up, up, up. And then I'm going to hit Shift down to select something on both of these lines, then Option down to move those out of the if statement. And I want to throw these in an else. So I'll type the open bracket and then the close bracket down there. And so now I've restructured it a little bit better to say, if there's nothing else, then print the confirmation. Otherwise, if there is something, then say there's other data. So let's try that one. So 1 and 2. Ah. Okay, this works in my notes. What happens if I comment this out? Nope. I'm running the right method. If anybody has any ideas, let me know. Okay. The only thing in my notes that I did differently is instead of, so I took everything from the scanner and I'm taking it directly from the scanner. Another way I could approach it, because this is clearly not working, is I could take the whole line from the scanner and then split it up. So I could do, and this is where we kind of get into scannerception, where we'll have a scanner that goes through something that I got from a scanner, where a scanner is just useful for chopping up and getting next tokens. And so we can use that on anything. We've used it on system.in. We can also use it on files or on just normal strings. So what we're going to do, so we could initialize it, or we could say in dot next line. And then so now that next line, that line that I type 1 and 2 is taken into this variable 1 line. And it's going to be a string. And so I'm going to want a scanner to go through that string. Let's call it something descriptive. 1-line scanner, it's a new scanner, and it's going to go through the string 1 line. Now, instead of going through in, I'll give it 1-line scanner to just say I'm going through something not system.in anymore. So this should work. There we go. Yeah. So now I can type 1 and 2 and enter, and then it finishes. And so the difference here is we take in the entire line, and then we've got a scanner that goes through that line. We can't use the same scanner to go through both, because the first scanner is set up to go through the console. We can't reassign it midway through. We set up one to take input from the console, and then if we want to go through something else, we need a different object. So we need this to be a separate variable. And so now let's test what if we give it 1, 2, 3, then it errors out. There's other data on the line. Hooray, it did what we wanted it to do. Ints not entered as required. Please provide 2 ints. So if we have some secret information later on, it doesn't allow it, which is what we wanted. All right, questions so far? All right, so what we did here is we took in the whole line from the scanner. We have a new scanner variable to go through that line. We can give a scanner just a string as an argument in its constructor, and then check the string. So I'm pretty sure if we comment these out, then these will also work. Maybe not. Okay. Perhaps not. This is something where when you're working on your homework, it's a lot of trial and error. So start early and run into problems early. And that way you can come ask for help, go to the STEM center and ask for help. They can't write code for you, but they can try and point you in the right direction. All right. Let's see if there's anything else I need to talk about. All right. So we don't have time for file reading. So my plan is probably on Tuesday, we won't do lab 3. On Tuesday, we'll talk about file reading. So we'll do the secret garden activity and the Magna Carta activity. And then probably on Thursday, we'll do lab 3 for the first part and then a little bit of review for the second part. So Tuesday, we'll talk about files, more scanner stuff. Then next Thursday, we'll do the lab. Thank you, and I will see you next time.